Okay, so exponential growth and decay, things that grow fast or things that die fast. If you need to go. Okay. Either one's okay. But. Mm-hmm. Okay, so what was I going to say? So first thing we got to do is find the formula, right? Find the formula using separating the variables to solve for to solve the derivative equation. Okay, so we came up with that. So after 1,000 years, we plugged in 1,000 years for t, came up with that. Okay, so next thing, same question, but now they want to know what will the mass be when? When will the mass be reduced to 30 milligrams? Okay, so if we go to our original table, they're telling us when R is 30. So that guy's going to be right here. What is that going to be, right? The glass question they gave us was, when this is 1,000, what is this going to be, right? So we plugged in 1,000 for t, and we got the answer. This one's the opposite. Okay, so they want to know when this is going to be 30. So we're going to plug 30 in for R. Okay. That's our formula. So we're going to plug in 30 for R. T. So we have to answer, we have to solve for t. Okay. So my question is, how do we do that? What's the first thing we're going to do? Get t by itself, right? T's up in the hills. T's up in the sky. But before we can bring it down to Earth, what are we going to do first? Divide by 100, right? So 30 over 100 makes 3/10. Okay. So we still got to get t now. So now we can bring it down to Earth. Now we can bring t down to where we can solve it, because we can't solve it if it's up in the powers. So, like we did the other day, I'm going to rewrite it. So E is on this side. So to go from exponential to log, we don't use the loop. We use what we did yesterday. We use the L or the boot, however you want to think about it. So the log of E, which is natural log, right, of 3 over 10 equals 1 over 1,590 times the natural log of 1/2 times t. Now t is back down to Earth. Now we can solve for it. So how do I solve for t? I got 4 options: add, subtract, multiply, or divide. Going to divide, right? So I would divide by the stuff I don't want. The stuff I don't want is this stuff here, right? One of them's a fraction, though. So I'm not going to divide this fraction. I'm going to multiply the fraction, right? Multiply by the reciprocal of it. So 1590. That'll take care of this. So I get 1,590 times the natural log of 3/10 equals the natural log of 1/2 times t, right? Now I can divide. Divide by the stuff I don't want. And that's when our calculator comes in handy. Okay. So we're going to put that in our calculator, see what we get. Okay. So we get 1,000. So what I'm going to do, you don't have to do this, but this is what I'm going to do. I'm going to divide the logs. I'm going to go log of 3/10 divided by log of 1/2. And then I'm going to multiply that by 1,590. You don't have to do it that way, but I think it's going to be easier that way. So calculation, log of 3/10, close parentheses, divided by log of 1/2, close parentheses. Okay. And then I'm going to take that answer and multiply it by 1,590. And there you go. 2,761,775. 3 places. Yep. So how did we measure time in this problem? Hours, minutes, years, days? This one was years because it was half-lives, right? So it's going to be years. Last thing you should always, always, always do is to see if it makes sense. Would 2,761 make sense on my table? Well, we found out when this was 30, right? Is that the question? Yes. So when radium was 30 milligrams, would 2,761, would that fit the pattern kind of? Yeah, it'd be in between. It's right in between 50 and 25. So yeah, it fits the pattern. So that's why yeah, you did it right. If my answer was bigger than this or smaller than this, you did something wrong. Somewhere went wrong. Okay? That's essentially what you're doing. Those 2 problems, one was an increase, right? One was a growth. This one was a decay. But it's the same problem over again. Okay? All right, so let's look at example 4. The last example, I believe, on here. Yes, the last example. Example number 4. Okay. So a manufacturing company determines that once it started a new television advertising campaign, its monthly change of sales was proportional. So they didn't say directly proportional, but sometimes they'll just say proportional. That means it's going to be exponential growth or decay. That means what we're doing fits into what we were doing earlier. So change of sales was proportional to the monthly sales. In January, it sold 5,000 units. And in April, it sold 7,000 units. Okay, so the first thing we got to do is write and solve a differential equation. Well, since it's exponential growth or decay, it's looking like it's growing from 5,000 to 7,000. So this is growth. Now we got to come up with our two variables. Instead of y and x, what are the two variables that we're measuring here? Time. In what unit of time? You're right. Time is going to be in what? Months. So remember, independent variable goes on the bottom. What is time versus what? What's the other variable? Units, sales, whatever you want to call it. Yeah, it's either units or sales or whatever. So you can use a U. I'm going to use an S for sales. It's the same thing. Okay. T is the independent variable. That's going to go to the right. S is the dependent variable. It's going to go to the left. Okay? But I'm going to give you a hint. This problem for A, wasn't it similar to the problem we did earlier, which was similar to the problem we did earlier then? Like we've done this 3 times, right? So for this one, let's kind of skip all of that and let's go right to the end. Let's see if we can do it. What is, not Y, S, capital S. What is S going to equal? Use the ones we've done before. E to the KT plus C. That's what's going to equal. And then we separated it, right? Because E to the C and E to the KT. The reason we separated it is because what does E to the C always represent? The start, the initial, right? That always represents that. Do we know what the initial is going to be here? We do. What is the initial? In January, right? Didn't it say in January? That's the start of the year. So in January, month 0, there was 5,000 sales. So that's going to be 5,000 times E to the KT. Now we need to make our table. So we have T in months and S in sales, units. So didn't we say our initial was 5,000? Right? What else do we know besides our initial was 5,000? So 7,000 in April. So let's write 7,000. What's April going to be? 3, yeah, not 4. A lot of people say 4 because April's the 4th month, right? But why would it not be 4? Exactly. January is 0. If January is 1, April is 4. If January is 0, April's going to be 3. Okay? All right. So now we're going to use that point to find out what K is. Okay? So everywhere there's a T, I'm going to plug in a 3. Everywhere there's an S, I'm going to plug in a 7,000. Oops. 5,000. E to the 3K. Because that's in April. Okay. Solve for K. Well, before I can bring it down to the ground, I'm going to divide by 5,000, right? So when you cross out all these zeros, it reduces to 7 over 5. Okay. So now I need to get k down to the ground. That calls for a log. So the natural log of e, the log of e is the natural log. 7 over 5 equals 3k. Divide by 3. K equals 1/3 times the natural log of 7 over 5. That's what k is the growth factor or the decay factor. It's growing by a factor of that guy. 1/3 natural log 7 over 5. That's the growth factor or decay factor. Since this one is growing in sales, it's a growth factor. If it's a decay, it's the decay factor. If it's dying, it's a decay factor. Okay, that's what k is. Okay, so now let's put it back in. So S equals 5,000 E to the 1/3 times natural log of 7/5 times t. That's our formula we're going to use to solve all problems about this. Okay, that's the formula we're going to use. Okay, so the next question says, how long did it take for sales to go from 10,000 units to 15,000 units? Okay, so they asking for S or T? What are they asking for? T, they want to know time, right? How long did it take to go from 10,000 units to 15,000 units? So let's go to our table. I know it took 3 months to go from 5,000 units to 7,000 units. But what they want to know is, how long did it take from here to here? So what I need to figure out is these two guys and subtract them. Right? How long did it take to get to 10,000 units? How long did it take to get to 15,000 units? I need to find those two numbers and then subtract them. Well, do we have enough data info to figure that out? Yeah, we got the formula, right? So use the formula. I want you to come up with time for 10,000. We'll do 10,000 together, and then I'll let you guys do 15,000 on your own. So 10,000. When sales are 10,000, what is the time? Okay. So 10,000 equals 5,000 e to the 1/3 times natural log of 7/5 t. Right? Solve for t. Okay, t's up in the sky. So first thing I got to do is divide by 5,000. $5,000 goes into 10,000 twice because it's half. Okay. Now we can bring down our power. the natural log of 2 equals 1/3 times the natural log of 7 over 5 times t. One-third, since one-third's a fraction, I'm going to multiply both sides by 3 first. Okay. Divide by natural logs. Calculator. So you know you should get a number that's bigger than 3 because it's going to take more than 3 months. How big is it? We don't know, but it's going to be bigger than 3. So let's put in our calculator. Natural log of 2 divided by natural log of 7/5 times 3. 6.180. 6.180. Okay, so let me go to the table and put that down. 6.180. For a little more than 6 months. Okay, so now what I want you to do is find out what time 15,000. When will they get 15,000 sales? All right, so let's see, 15,000. For 15,000, I got 9.795. 9.795. For this one, we got 6.180. I'll do 15,000 right now, but that's what I got, 9.795. So almost 10 months. Okay, so we have 15,000 units equals 5,000 units. 1/3 times the natural log of 7/5 times t. Divide by 5,000. You get 3 equals equals e to the 1/3 natural log 7 over 5 times t. When you change that, you're going to get natural log of 3 equals 1/3 times natural log of 7/5 t. Multiply both sides by 3. Divide by the natural log you don't want. You get t equals 9.795. Okay. So how long did it take to go from 10,000 to 15,000? Just subtract them. So you subtract the big number minus the small number, and you get around 3.6. It's a little over 3.6. A little over 3.5 months to go from 10,000 sales to 15,000 sales. Okay? This is how companies predict how many they're going to sell. Like, the new iPhone comes out every year, right? Around September, October, the new iPhone. They already know how many they're going to sell. They already know they're going to sell this many iPhones for an iPhone that hasn't come out for like 6 months. How do they know that? Because they know the growth factors. They know growth factors of past iPhones, and that's why they keep making one every year, because they know it's going to sell. If it didn't sell, they wouldn't put it out. Okay, so we finished a little early.